OCI, Orange County Inspections, is glad to present the following. The Quality Control and Quality Assurance Professional Seminar, segment number 11. The topic of this segment is the non-destructive testing, or also known as NDT. With any useful quality control program, it should be able to determine the compliance of a given base metal or weld assembly. As we've seen earlier in this seminar, one way to evaluate the subject's compliance is to perform a destructive test. But the major disadvantage of this approach is that the test subject is destroyed during the process. So a number of tests have been developed to provide an interpretation of the compliance for the test subject without destroying it, and these tests are referred to as non-destructive testing. Each one of these test methods have different advantages and limitations, so it's very important to select a method which will provide the necessary results. As we review the three major methods most used in the welding industry, we will provide a description of the necessary equipment and base principles of the operation. First, we will cover the ultrasonic testing method, or also known as UT, which uses a high-frequency sound wave, well above the human range of hearing, to perform the UT test. The transducer is attached to an electronic base unit which creates a sound wave that is transmitted through the test object until it encounters some reflector, which makes it bounce back to the reducer and ultimately displays on the visual screen for interpretation. Next, we cover magnetic particle testing method, and once again it's also known as MT. This method is used primarily to discover surface defects, which has a subject being magnetized and iron particles sprinkled on the test area that creates an accumulation of these particles that reveal the defect for visual interpretation. And lastly, we cover penetrant testing method, or PT as it's also known. This method also reveals surface defects by applying a liquid penetrant to a clean surface of the subject, and after a prescribed time called dwell time, a liquid developer is applied which draws the penetrant from the defect out for visual interpretation. The first topic is the ultrasonic test method. The UT method is applicable to almost all materials and can be used to detect both surface and subsurface defects. But a limitation for this method is any material and process that produce large size grain tend to scatter and disperse the sound wave, which makes it very difficult to examine. The UT method uses the transmissions of mechanical energy in waveform at frequencies above the audible range. A transducer transmits a sound wave into and through the material, which then the sound wave is sent back when a reflector or defect is struck. And this is then displayed on the screen. Now, when examining groove welds, both the amount of testing and the equipment are specified by the AWS D11 code. In addition, the equipment must be calibrated using a standard reference block for a setup of vertical and horizontal scales on the screen, plus the technician must be certified by the ANST, American Society for Non-Destructive Testing. Now, there are two basic types of transducers, and we look at the longitudinal wave, or also known as the straight beam, which is used to determine material thickness or depth of a defect below the surface face, plus also used for checking lamination in heavy thick material. This is basically done by transmitting the sound into the subject perpendicular to the surface face. Second, we look at the shear wave, or also known as the angle beam, which is used widely for weld compliance due to the fact that it sends the sound into the part at an angle, allowing testing to be performed without the need for removal of any weld roughness. Second topic of the segment is the magnetic particle testing method, or also known as MT. This method is used to discover surface defects. The MT method magnetizes the subject, then iron particles are sprinkled on the surface, which become magnetized and will accumulate, that produces a visual indication of the defect. There are two types of magnetic fields which are typically used, and the yoke unit will create a longitudinal field. The yoke unit is made by winding a coil around a soft magnetic material core, which creates a current that flows across the test object between the ends of the yoke. The second magnetic field used is the prod method, which creates a circular field. The prod unit uses a portable unit which uses either AC or DC currents to induce a magnetic field. A quick tip is that the AC current is the strongest at the surface of the test object, where the DC current induces a greater penetrating power. Looking at the dry particle testing method, the iron particles used are very small and often dyed to provide a vivid color contrast which reveals the defect. These magnetic particles are applied with a low velocity airstream. And now, with the wet particle testing method, the iron particles are inhibited in water or light oil that is ran over the test piece, which creates a fluorescent visual of any defects when viewed under a black light. Due to the movability limitations of the equipment, this method is primarily used in a laboratory setting. And here is an example of a wet particle test defect. The third topic is the dye penetration testing method, also known as PT. The PT method will reveal surface defects and must have a very clean surface prior to moving to the second step of the process, which a penetrant, usually a liquid, is added to the object, and once allowed to be drawn into the test piece called dwell time, step number 3 can be performed. All excess penetrant must be removed, and the application of a developer takes place which draws out the penetrant from the defect. And the result is an indication shown as a high color contrast which magnifies the presence of the defect for visual interpretation. Here is a typical set of PT cleaner, penetrant, and developer canisters used within the test method. And here is an example of the finished reveal of the defect. Again, here's another example which shows why this test method is very practical on objects that could be missed by any visual observation. We have added this special bonus topic to this segment, the NDT Resource Center. This very helpful website makes non-destructive testing a much easier industry to understand. First, this site was created with funding from the National Science Foundation for the sole purpose to create a stronger focus on the NDT education via the Internet. This site helps the student to design professional by providing excellent graphic, dynamic, and interactive material. This site's mission is for the material to be used and critiqued with the hope that it will raise the quality that will accomplish the goal of serving educational material to the NDT community. Second is the website's location, which is ndt-ed.org. Now, to show how this site helps you, the QC and QA professional, when you come to the home page like we see here, you will need to click on this image, which takes you to this page, the NDT course material page. When done reading the information, just click on one of the test methods available to you, and for this topic we will choose the PT method found here. Now we are on the PT test method page, which unlocks the power of what makes this site so excellent. First, we see the section for the introduction of the PT test method, and also notice the subsections that when clicked on will take you to another page for that provided information. Second section is for the principles of the test method. Third is the material for the test. Fourth are the methods and techniques for the test. Fifth is the quality and process control required for the test. Sixth covers any consideration for the method, and now notice two important subsections here. First is the references used with the PT test method, and second is the quizzes provided for helping the student. We have come to the end of this segment, and let's review the topics we covered. First, we reviewed the requirements for the personnel, product, and procedure for the test methods of ultrasonic, magnetic particle, and dye penetrant, while alerting you that an ASNT certification is required to perform these tests. Second, you have seen an excellent site that unlocks resource material on the NDT industry, plus while also providing both reference and quizzes to refresh or increase your knowledge on the field of NDT. Third is the study material for this segment. Review the NDT Resource Center site, then study the material and take quizzes provided for the UT, MT, and PT test methods. Then read the following guides: the International Atlantic Energy Agency's NDT Techniques Guide, and the American Bureau of Shipping Guide for NDT. If any questions arise, email orangecountyinspections@yahoo.com. When completed, move to segment number 12.